Integration by parts. Now, where all the other methods that you have learned so far may fail to integrate to find the antiderivative of a given expression, this rule, which represents integration by parts, the rule for integration by parts, will help you find your solution. I recommend that you pause the video over here at this point in time and then have a look at the derivation. What we're basically doing over here is considering the product of two different expressions, two functions, f of x and g of x, applying the product rule. The result we get, we integrate all the terms in here. On this side, or for this particular term, the integral and the derivative, they cancel to give you f of x times g of x is equal to the integral of the remaining expressions. And a little bit of rearrangement by making this the subject of the formula, so that this expression, the reason why I make this expression the subject of the formula is because this resembles very closely to u dv. So now we see that we get the integral of f of x, which is my u, g dash of x dx is my dv, is equal to f of x times g of x minus the integral of g of x times, this is my v again, and this whole thing must be du. So to be able to integrate using integration by parts, we got to do some groundwork first. In this case, we got to split and identify u and dv. So in this case, I would let my u to be x and my dv to be the remaining expression, which is sine of 3x dx. I differentiate u with respect to x, I end up getting du is equal to dx. I integrate dv and I integrate sine of 3x with respect to x. Over here I get v is equal to 1/3 or negative 1/3 of cos of 3x. And after that, it's just writing the rule for integration by parts and carrying out the appropriate substitution. So my u was x times negative 1/3 cos of 3x minus negative 1/3 the integral of cos 3x du. Now, since du is the same as, right, that du over here, but that in fact is the same as d of x, I can rewrite this expression using d of x. Now I've got to integrate cos of 3x with respect to x, which is much easier, and it can be done, it can be accomplished. So my final answer, negative 1/3 x cos of 3x plus 1/9 sine of 3x plus a c. In the next example, we're going to integrate ln of 3x minus 2 with respect to x. Once again, you identify your u and dv. In this case, my u is this whole expression, ln of 3x minus 2, and my dv is the remaining expression, which in this case is just dx. So u is ln of 3x minus 2, dv is dx. Differentiate u with respect to x and make du the subject of the formula. I get 3 on 3x minus 2 dx, and integrate dv equals dx. I get v is equal to x. And after that, once again, I start by using the rule, write the rule, carry out the substitution, u times this pass my v minus v du. If I multiply x by du, I get 3x on 3x minus 2 with respect to x. Now, this expression can be simplified using long division, and that gives me 1 plus 2 on 3x minus 2. And after long division, the integral of 3x over 3x minus 2 becomes much more easier. So I replace that whole expression by the integral of these two terms, and I finally end up getting x times ln of 3x minus 2 minus the integral of 1, which is x, minus the integral of this whole expression, which is 2/3 ln of 3x minus 2 plus ac. I would like to encourage you to investigate the LIATE method. This method actually helps you determine which sort of substitution, or what sort of choice you make for u and for dv. Now, that's one of the most important steps in integrating, while integrating using integration by parts. So you got to know your u, you got to know your dv, and this method will help you determine your u and dv. Here's another method, integrating by parts using the tabular method. If you're given an expression of the form px times f of x with respect to dx, I would like you to once again pause the video over here, read all the steps, the 5 steps that are involved. Basically, what is involved over here is a repeated differentiation of p of x and repeated integration of f of x. You keep differentiating until you end up with 0, and you keep integrating to that particular point. Now, you see over here x squared minus x, I differentiate, I get 2x squared, 2x minus 1, differentiate again, I get 2, differentiate again, I get 0. I draw an arrow from this first row to one row down the next column, and I put a plus over there. Do the same for the next and for the next expression, and these signs keep alternating between plus and a minus. And after that, you multiply these two terms. So negative cos of x times x squared minus x, whole thing times positive 1, plus 2x minus 1 times negative sine of x, and whole thing multiplied by negative 1, and so forth. And you write all those products as sums. That will give you the final integral.